My computer ran out of memory in the middle of this problem, so let's go back and refresh our memory. Somebody wanted said 8x cubed plus sine of x, and so we got 2x to the fourth minus cosine of x plus a constant. And then we were given that f of 0 equals 2, so when we put 0 in for x, we should get out 2. And if we do that, we get 2 times 0 is 0, cosine of 0 is 1, so we get negative 1 plus c is equal to 2, so we get c is equal to 3. So the solution to this initial value problem, or the particular solution to the differential equation, is 2x to the fourth minus cosine of x plus 3. So another type of problem that you'll get in this section deals with position, velocity, and acceleration. And the main thing that we need to remember with position, velocity, and acceleration is that if we have position, the derivative of position is equal to the velocity. And if we have velocity, the derivative of velocity is equal to acceleration. And so if we're given acceleration and we're asked to go backwards to get velocity, we take the antiderivative of acceleration to get velocity. We take the antiderivative of velocity to get back to position. And then we can be given some initial values to solve for the constants in those cases. And so that's summarized here. Let's do a couple of examples, and then we'll be done with this section. So let's look at number 91. I've written this one out to save us some time. So it says v of t is equal to 2t plus 4, and s of 0 is equal to 0, and it wants us to go from the velocity function backwards to the position function. So looking at this, we are starting with v of t equals 2t plus 4, and I want to go backwards to position, so I'm going to take the antiderivative of 2t plus 4. Antiderivative of 2t plus 4 is t squared plus 4t plus a constant. And then I'm going to use this initial value to solve for the constant. So I put in 0 for t, and when I put in 0 for t, this says I get out 0. And if I do that, I solve for the constant, I get c equals 0. Going from acceleration to position, that means we need to take 2 steps backwards. We need to go from acceleration to velocity and velocity to position. And if you notice here, they gave us 2 initial values because we need to go backwards twice. So I'm starting with acceleration, and I take the antiderivative of acceleration. Antiderivative of negative 32 is negative 32t plus a constant. I'm going to call that constant 1 because we're going to have 2 constants in this problem. This says when I put in 0 for t, I should get out 20. So when I put in 0 for t, I get out 20, and this tells me that c1 is equal to 20 because that will go to 0. So now I rewrite my velocity, v of t equals negative 32t plus 20. c1 is equal to 20. So now this is my velocity function, and I need to go back one more step to position. So I'm going to take the antiderivative of velocity, antiderivative of negative 32t, this is to the first power, I would add 1 to that. I get 2, divide by 2, I get negative 16t squared plus 20t plus the constant. And then this tells me when I put in 0 for t, I get out 0. And if you solve that, that goes to 0, that goes to 0. We're left with c2 is equal to 0. So we're left with negative 16t squared plus 20t. We're going to look at one last example with motion. Consider the following descriptions of the vertical motion of an object subject only to acceleration due to gravity. Begin with acceleration equation. A of t equals v prime of t equals negative g, and they tell you that g is 9.8 meters per second squared. So basically they're telling you that you're starting with a of t equals negative 9.8 meters per second squared. Because a of t, 9.8, we're putting that in there, so we get negative 9.8 meters per second squared. Part A, find the velocity of the object for all relevant times. So if I want to go backwards from acceleration to velocity, I have to take the antiderivative of acceleration. So what do I take the derivative of to get negative 9.8? I have to take the derivative of negative 9.8t plus a constant. Now, I kind of didn't even read the problem here. We're doing problem 107. It says a softball is popped up vertically from the ground with a velocity of 30 meters per second. So when I do this problem, this is telling me that the initial velocity is equal to 30 meters per second. And so I know when I put in a time t equals 0, I need to get out 30. Put in t equals 0, this is going to go to 0, and I get c1 is equal to 30. So for this particular problem, v of t is equal to negative 9.8 t plus 30. Then it says find the position of the object for all relevant times. Well, to find the position, if we are given velocity and we want to go backwards to position, we have to take the antiderivative of velocity. So this is like 9.8 t to the first. And so I add 1 to this 1, I get 2, and I divide by 2, I get negative 4.9 t squared. The antiderivative of 30 is 30t. What do I take the derivative of to get 30? The derivative of 30t is 30. And then I have a different constant here. So I also need to go back to how the problem is written. It is popped up vertically from the ground. Because it's coming from the ground, that tells me that its initial position at time 0, is equal to 0 because it was on the ground. So when I put in t equals 0, I need to get out 0. So when I do that, I end up solving for c2. This goes to 0, this goes to 0, leaves me with c2 is equal to 0. So my position function is here. And then two common types of questions. Two common types of questions that go along with this. Find the time when the object reaches its highest point. Well, if you think of this ball flying through the air, that when it reaches its highest point, it's going up, 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 reaches its highest point, and then goes back down. At that moment that it's at its highest point, its velocity is equal to 0. And so I want to know when the velocity function is equal to 0, so I'm going to take my velocity function and set it equal to 0. And if you set that equal to 0, you get, and solve for the time, you get 3.06. So there's really not any calculus involved in that question. You're just using the equations that you found using calculus. And then it wants to know the height at that time. Well, I take that 3.06 and put it back into the position function. That will give me the height at that time. Probably should put units on here. This is 3.06 seconds. And this is, I think, in meters. Yep. Okay. And then the last one, find the time when the object strikes the ground. Well, when the object is striking the ground, that's telling you that your position of the object is 0. So you're going to take your position function and set it equal to 0 because that's the ground. We want to know when it's on the ground. Well, it's on the ground. If we factor out a t, we get t times this stuff. And so it's going to be on the ground at t equals 0. We already knew that. And it's going to be on the ground when we set this equal to 0. So we're going to subtract 30, divide by negative 4.9, and that's about 6.12 seconds. And so that's the last type of problem. And then you have your practice and your MML quiz. Please let me know if you have questions, and enjoy.